Right. Okay. Record. And then share my screen. Nakikita na ninyo akong share screen? Is it visible now? Anyone?
Yes, ma'am.
Right. Alright. Let's proceed with our discussion. No, last time we ended our topic with the basis. Now, the last topic for this subject is the eigenvalue and the eigenvectors. An eigenvector of an n by n matrix A is a non-zero vector x such that ax is equal to lambda x for some scalar lambda. So, si eigenvector is the x in this equation. Okay, si x is the eigenvector for some scalar lambda. A scalar lambda is called an eigenvalue of A if there is a non-trivial solution of ax equals lambda x. So si scalar dere, scalar lambda, si lambda is the eigenvalue. Such an x is called an eigenvector corresponding to an eigenvalue lambda. So if you can get the eigenvector, we can also get the eigenvalue corresponding to that eigenvector. So scalar lambda is an eigenvalue. Again, si lambda is the eigenvalue, si x is the eigenvector of an n by n matrix A if and only if lambda satisfies the characteristic equation. If this equation is satisfied. So we have here a determinant. So that here refers to the determinant of the matrix, the given matrix A minus the lambda, which is the eigenvalue, times the identity matrix. So this determinant of matrix A minus lambda times the identity matrix is equal to 0. This is satisfied, then your scalar is correct, and meaning your lambda is correct, and as well as your eigenvector. Okay, how are you going to find your eigenvalue and eigenvector? So we let A, matrix A be an n by n matrix. Okay. First, we find the eigenvalues lambda of A by solving the equation determinant A minus lambda I equals 0. So what we're going to do is we find the eigenvalue first, the lambda, and we use this equation, determinant, where our A is the given matrix and I is our identity matrix. The determinant here refers to the determinant operation. Okay. After we find the lambda, for each lambda, find the eigenvector. We then find the eigenvector after the eigenvalue. Adjust lang ah. Adjust lang kayo. But then. Okay, so after we find the lambda, we find the eigenvector using this equation. So we will find x. Okay, you know x is our eigenvector, diba? So we find the basic solutions to ax equals lambda x. So we find in finding the lambda, we use this equation. Then after finding the lambda, we will use this equation to find the x. or the eigenvector. Okay, to verify your work, make sure that AX is equal to lambda x for each lambda and associated eigenvector x. So if you want to check if you got the correct eigenvalue and eigenvector, you may check it using this equation. If you found out that this is equal to this, then your eigenvalue and eigenvectors are correct. Okay, of course, make sure that for each lambda eigenvalue, you will use its associated or its corresponding eigenvector for upon checking. Okay, if you use lambda 1, for example, make sure you use the same eigenvector or the eigenvector that you got when you use the lambda 1, right, for example. Okay, we have this example. Now we let A be the matrix. With this matrix, determine if X, which is this eigenvector of A, is really an eigenvector of A. Kanisya is checking lang if this is really the eigenvector of this an eigenvector of this matrix. So are you going to do that? For the solution, okay, wait lang. This is checking lang. So we're not going to find any eigenvalue and eigenvectors yet. So in checking, you may use this formula. So you check if this is actually an eigenvector of this matrix. You use this formula. So we have AX. So we have given AX equals lambda x. Okay. Now substitute AX. So we have 1, 6, 5, 2. We times this 2, multiply this 2, the vector, eigenvectors. You have 6, negative 5. Now you solve. Again, solving, multiplying two matrices. Or matrix multiplication. So this is compatible, right? So there is 1 times 6 plus 6 times 5. I hope you can still remember. So we have 1 times 6 is 6. 6 times 5 is negative 30. So 6 minus negative 30 is negative 24. Okay. So we have 5 times 6 is 30 plus 2 times 5, negative 5, 10. So we have 10 minus 20, 30 minus 10. So this is 20. Now, what we're going to do is you express this into this form. Para makita na to if this x here is really an eigenvector of this matrix. So what we're going to do is we want to express it in this form. So we factor out some scalar para mapakita nato nga this matrix is really an eigenvector. So what we're going to do is you find a scalar that would fit to this equation. What would be the scalar here? What do you think would be the scalar? Pila to i-times diri, para kung atong i-times din siya sa 6, may mo siyang 24. Pila man? What do you think? Tulog pa man guro mo ah.
4, ma'am.
So we multiply 4, but this is negative 24. What do you think?
Negative 4,
4
ma'am.
lang or negative 4? So we put negative 4 here. So we have negative 4 times 6 is 24. Similarly, if we multiply negative 4 to 5, that is positive 20. So kani. So therefore, since this x exists, and this one here is your lambda, your eigenvalue corresponding to this eigenvector. Therefore, the vector x is, anong the x man eh? Lang ba? Therefore, x is an eigenvector of A. 6, negative 5 is an eigenvector of A, matrix A. Okay. Follow first example. How about the second example? So again, AX minus lambda x. So your AX is 1. Ay, nagbalik. Ay, lahi na po day ang x. Again, 1, 6, 5, 2. The same ra siya, no? The same ra siya nga matrix, but different na vector. Well, we are going to take a look if this eigenvector is really an eigenvector of this matrix A. Right? So 1 times 3 is 3. 6 times 2 is 12. So 3 minus 12 is 9. 5 times 3, 15. 2 times negative 2 is 4. So 15 minus 4 is 11. Can we find a scalar here that, I mean, not here. Wait lang. Can we find a scalar here that if we multiply that scalar to our x, it will result to this matrix? Nabatay makita ang scalar? Yes or no? Yes or no?
No, ma'am.
No, wala tayong makita ang scalar, di ba? Nga common nila, nga every time we multiply it to each of the elements in this eigenvector, it would result to this to this vector. Wala. So therefore, this 3, negative 2 is not an eigenvector of A. Okay. Follow? Questions, clarifications on these examples? Right, let's proceed. This is now in finding the eigenvalues and eigenvector. Right, so we let our given matrix be negative 5, 2, negative 7, and 4. Now, this time we are going to find the eigenvalues and eigenvector. So again, we'll start with finding the eigenvalues. So, unsa itong formula in finding the eigenvalue? We have determinant of A minus lambda I equals 0. Diba? Then we find the lambda. Okay? So, taking this first, so we have A minus lambda I. This is equal to, of course, you're given A, negative 5, 2, negative 7, 4. Diba? And then we have scalar lambda times I. Identity matrix, we have 1, 0, 0, 1. Okay? Now, let's compute for this. So, this is equal to negative 5, 2, negative 7, 4. Okay? Minus, of course, this is scalar. We can distribute this to our identity matrix. So, we have lambda, 0, 0, lambda. You message me or you put in the chat box your questions para while I was explaining, I am explaining, makita na ako kung na yung mga clarification, right? Na mga wala nasabtan. Right? Now, let's, of course, subtraction of matrices. Of course, we can do that entry by entry. So we have negative 5 minus lambda. Negative 5 minus lambda. We have 2 minus 0, so we have 2. 7 minus 0, so 7. And then 4 minus lambda. 4, negative 7. Palimot na. Negative 7 minus 0 is negative 7. Then 4 minus lambda is 4 minus lambda. Okay? So this is now your A minus lambda I. Now, we are going to get the determinant of A minus lambda I. So the determinant of this, so this is equal to, of course, you can still, I hope you can still remember the getting the determinant. This is just a 2 by 2 matrix. So, ano lang, so we have kani times kani, minus kani times kani. Right? So we have negative 5 minus lambda times 4 minus lambda minus 2 times negative 7. Right? Now, of course, we solve. Pila man ni? Pila ning duha ka polynomial, multiply nimo, pila? We have, anyone? Sa isa lang, para dali ra na to makuan. Masabtan. We can do this. You can still remember, no? Kana, ni, dali ta mag-libog. Kanina yun. Okay? So, negative 5 times 4, we have negative 20. We have negative lambda times 4, negative 4 lambda. Next, we have negative 5 times negative lambda. So, we have positive 5 lambda. Negative lambda times negative lambda, we have positive lambda square. Okay? Kinani? Now, kanina po dayon, we have negative 2 and negative 7. So, we have positive 14. Algebra. So, dapat ma-recall ninyo ito yung algebra sa high school. Right? Next, simplify. Of course, we'll start with the highest exponent. So, we have lambda square. Kani, this is negative 4 lambda plus 5 lambda. This is, of course, 4. Negative 4 plus 5 is 1. So, we have lambda la. And then we have negative 20 plus 14. We have negative 6. Right? So now remember this one here is equal to 0. So we will equate this to 0. We have this equation now. What we're going to do is we factor out this expression. So what would be the factors now? We have lambda, what? Lambda plus times lambda minus. Pila? Factoring. Okay, factoring. What are the factors of 6 that would result that if you are going to add it, it will result to positive 1. Factors of 6,
3 and
right?
2, ma'am.
We have 3 and 2. So we have 3 na positive and 2 na negative. So we are going to add this 3 plus negative 2. May mo siyang positive 1. So these are our factors now. Therefore, we can say that your lambda 1 is equal to negative 3, and your lambda 2 is 2. Now, kung mangutana mo na unsa ni, this is, isa ha, dire na dapit. Lambda plus 3 equals 0. We have lambda equals negative 3. For lambda minus 2 equals 0, lambda equals 2. So this is your lambda 1, this is your lambda 2. Munang na ani. These are now your eigenvalues. So we have two eigenvalues, negative 3 and positive 2. Now we're going to find its corresponding eigenvector. Right. So we have here, again, finding the eigenvector, we're going to use this formula. Right. Now, nanatay lambda, nanaputay A. Ang wala sa ato is the X. So, at lambda 1 equals negative 3, we can have X. Say, we'll name it A and B. Now, what we're going to do is we identify this A and B. That is now our, what? This will be now our eigenvector. Right? Using this formula, going back, we have AX. AX is equal to, wait. Okay, so we're going to use this. So we have your A is negative 5, 2. Then we have negative 7 and 4. Right? Your X, again, is A and B. And then your lambda is negative 3. So we're going to use this one. One is the A, si X, si lambda, equal na siya. Si lambda, one nga value. Then we have X. You times it with A and B. Multiply with A and B. So, compute. Right? Now we compute negative 5 times A plus 2 times B. So we have negative 5A plus 2B. We cannot merge this one. No? They have different variables. Next, we have negative 7A plus 4B. So we have negative 7A plus 4B. Okay? This is equal now to this one. So we distribute the scalar to the vector. So we have negative 3A and negative 3B. As you can see, we have now a system of linear equation. Right? Convert this. So we have negative 5. Express this as a system of linear equation. This is equal to negative 3A. And then your negative 7A plus 4B is equal to negative 3B. Now you solve. However you want it. You may use RREF, substitution, elimination to find the solution set A and B. The solution set of A and B. Right? Depende on sa inyong buhaton. The same raman nag-result. Okay, let's try using substitution. So from 1, meaning equation 1, we're going to find the value of B in terms of A. So we tanang B diri tapos dito balhin na to ang A. So we have negative 5 plus 2B equals negative 3A. So we have 2B equals negative 3A plus 5A. So from this equation, gibalhin na to si 5A didhi. May mo siyang positive. Muna siya. We have negative 3A. Si 2B na lang nabilin. Right? Say next, ani. Simplify. We have 2b equals, this is 2a. Therefore, b is equal to a. Right? Now, we substitute this to our second equation para makuha na to si a. Right? Next, we have a substitute. Substitute b to equation 2. Okay. So, tanan daw ko ng b ni equation 2, himuon na to siyang kene. A. Right? Again, negative 7a plus 4b equals negative 3b. We substitute b to a. Okay, b is equal to a man daw. So, ilisa na to tanang b sa a. So, we have negative 7a plus 4b equals 3, 4a. Ilisa na to tanang b sa a. Equal naman daw na sila. According to this. Okay, so tanang b mo na tong a. So, we have 4a, dayon 3a. Negative 3a. Hapit na nalimutan sa negative. Right? So, di po tanang variable. So, we have negative 7a plus 4a plus 3a equals 0. So, balhin na to si negative 3a dire. May mo siyang positive. Okay, balhin mo na to. Transpose. Right? So, we have 4a plus 3a is 7a. Now, we have negative 7 here. So, we have 0 equals 0. Kita pa ba ninyo? What does this mean? So, pasabot ani. We have 0 equals 0. Now, if we have RREF here, di ba kung 0 equals 0, may mo siyang what? We have multiple solution. Right. I hope you can still remember that. Right. Now, since it has multiple solution, we let A be any scalar S. For example, any number S. Then your B is just equal to S. Right? So for the first eigenvector, we can get, this is A and B, diba? We can get vector S and S. Okay, equal naman silang duha. So A is S, B is S. Then we simplify this. We factor out your S so we can get the vector 1 and 1. Now this now is your eigenvector 1 and 1. So therefore, for eigenvalue equals negative 3, your first eigenvector would be equal to 1 and 1. Right? So that is for the first eigenvalue pa. Now, we still have to find the second eigenvalue. So at x eigenvalue 2 equals 2 from here, right? Kani? Diba? Manata sa negative 3, negative 2 na, 2 na punta. So for 2, again, we go back to this process. We have x equals a and b, right? Next, we use the equation ax lambda x, ax equals lambda x, right? Substitute the values. We have negative 5, 2, negative 7, 4. Your x again is a and b. This is equal to 2 now for your lambda, and then the same a and b. As you can see, it's just the same process as this one, such that ang difference lang niya is kanina'y lambda. Right? So therefore, we can proceed with this. So we have negative 5a plus 2b, negative 7a plus 4b. The same na sila. Dari. O kani. Ang naglahi lang is diri 2B na, 2A na, diri po 2B. 2A. Right. Okay. Now, again, systems of linear equation. We have negative 5A plus 2B equals 2B. Dari negative 7A plus 4B equals 2B. Now, again, the same process. We are going to find A and B. So, this is your equation 1. This is your equation 2. From 1, we find the value of B in terms of A. So, we have 2B equals 2B. Ay, wait. This is A. Anong B man eh? Diba? Anong B man ka? This is A. Pero, this is A. Tingala po ka. Okay. So, this is 2A. Erase. 2A. Balin si A dito. So, we have positive 5A. Now, we get 2B equals 7A. Right? Your B is equal to 7 over 2A. Say na natay B. Again, we substitute this B to equation 2 para makuha si A. So, substitute. Diba na kahit tagisulat? B equals 7 over 2A to equation 2. Okay? After that, equation 2 is 7, negative 7A plus 4B equals 2B. So, substitute B. We have negative 7A plus 4. Pila ang B? We have 7 over 2B. Ay, A. 7 over 2A. Wait lang ha. Sorry na po. 7 over 2A. Ilisan si B to this one. Nanganing B. This is equal to 2. Again, your B is 7 over 2A. Right? Now, let's compute. We have negative 7A plus, pila man ni? May muning 2, may muning 1. So, 2 times 7 is 14. A equals, ilan ni? 2, 2, so 7A. Balhin na to dito sa pikas. We have negative 7A plus 14A. Balhin ni, so we have minus 7A equals 0. 7, negative 7, and negative 7 is negative 14. So, we have negative 14A plus 14A equals 0. So we have 0 equals 0 again, meaning multiple solution. Right? So we have multiple solution. We let A be equal to S. Then your B is equal to this one. If your B is 7 over 2A, this is equal to, if your A is B, then your B is equal to 7 over 2S. Right? So we have A and B now. For your x2, we have A and B. This is equal to S times 7 is S and 7 over 2S. Right? We factor out this one. Actually, we can do multiplication of scalar para ma-simplify this. So we can get 2S So we can get 2s and 7s. Okay? Then we factor out s. So this will become now, wait a minute. This will become now s 2 and 7. So for lambda 2 equals to your x2 or eigenvector is equal to 2 and 7. You want to check if your eigenvalues and eigenvectors are correct, you can use this ax equals lambda x. Substitute, of course, for each corresponding eigenvector, make an eigenvalue, make sure that you have the corresponding eigenvector used in this equation para sakto ang imong makuha na answer. Okay, you can check if you want, and then yeah, para makita ninyo kung correct ba or dili. So, we have get our eigenvalues and its corresponding eigenvector. So, first eigenvalue is this one, eigenvalue and eigenvector. And then this is your second eigenvalue and eigenvector. Okay? Questions, clarifications? While you are looking at the or internalizing the discussion, no, I'll get your attendance. So, put my note. 1C.
Bandi, ma'am.
Questions? May pangutana? Ay, 1D mo. Tama. Very 1D. Wait. Lang. Dito ka. Right, Anay. You state your apelido and say present ha. Anay. Aranjuez. Arizalita. Avila. Azores.
Present Azores, ma'am.
Balistoy. Palyarta.
Yes, Balyarta, ma'am.
Present Balistoy, ma'am.
Cagas. W.
Kagasint, ma'am.
W present, ma'am.
Dumanon. Imata. Tera. Perolino. Perolino. Hidalgo. Habonilla.
Hidalgo.
Perolino, ma'am, present.
Present Hidalgo, ma'am.
Okay. Wala era ba? Habonilla, wala. Perolino and Hidalgo. Ladao. Mier. Nakalaban.
Present niya, ma'am. Nakikuan lang ko kang Hidalgo nga phone kay nalobat ko.
Isa na, si Mier na.
Yes, ma'am.
Obidencio. Wala yung bar.
Present ang kalaban.
Present nomination.
Obidencio.
Ang
Oreo.
kalaban.
Okay
Present,
na.
ma'am.
Padiran. Pauline.
Present Padiran, ma'am.
Present pa rin, ma'am.
Padiran.
Rondina. Sikat.
Present, ma'am.
Sikat
Sikat.
present, ma'am.
Tarugo, Sandigan, Kabilugan, Tinyo. Okay, doesn't be absent. Tinyon, Kabilugan,
Percentinyo, ma'am.
Tinyo. Okay. Tinyo, Kabilugan, Sandigan, Tinyo present na siya. Tarugo, absent. Olaivar, Ladao, Abonilla, Era, Imata, Dumanon, Avila, Arizalita, and Arangues. Okay. Yes, I will post it. I will upload this discussion in the drive. Even ang katong kuan kaning computation ng agya po ni dito sa drive. Right. Is there any other clarification with the discussion? So, yes, Dumanon. Dumanon. So, attendance imong concern. Okay, present. Anything else? Right, so at home you practice solving this second example para para ma-practice mo sa inyong balay. Then era. Right. Practice and then Okay, so this is katong example ganina is 2 by 2. We have two eigenvalues. 3 by 3, possible 3 eigenvalues. Okay, so you practice this one also. Now let's proceed with the Cayley-Hamilton theorem. So this is just related to eigenvalues and eigenvector, no? So we let A be an n by n matrix with entries in a commutative ring with identity, and let P alpha equal to the determinant of A minus alpha 1, B lambda, P lambda is equal to the determinant of A minus lambda I, which is equal to this one. So this equation now is our characteristic polynomial. So I think I already mentioned this earlier. So what we're going to do is that we are going to prove that A satisfies its own characteristic polynomial. So so from this equation, we replace all our lambda here to A. As you can see, we have P of A equals to the same with this. So all our lambda will be replaced with A. So meaning this A satisfies its own characteristic polynomial. So for a start, right? So again, for a start now, we're going to find its characteristic polynomial. It's just the same with the first process in finding the lambda, the eigenvalue. Right? Same process. You substitute the values of A minus, of course, lambda scalar. This is the identity matrix. Right? Then we solve, and we arrive this. Ibalik ko na lang na po. So, we solve, no? So, we have 1 minus lambda, monideri, then 3 minus 0 equals 3. 4 minus 0 is 4, and 5 minus lambda is kani. Then we get its determinant. Now, remember, we get the determinant. So, getting the determinant, we have kani times kani. So, we have 1 times 1 minus lambda times 5 minus lambda. So, we have 1 minus lambda times 5 minus lambda, money, minus 3 times 4. So, money na dere. We multiply these two polynomials. So, we have this equation now. We have 5 minus 5 lambda minus lambda. Then we have lambda squared minus 12. So, simplify. This will now become our characteristic polynomial. lambda squared minus 6x minus 7. Okay, the same process in finding the lambda kaganina in our eigenvalue. We're just going to end in this form. Now, after that, we are going to replace all our lambda here by A. So your A is this matrix. So P of A is equal to A squared, as you can see, minus 6 lambda minus 7 times identity. So, kung tanaw ninyo diri, ang last niya nga coefficient na siya i-multiply na identity matrix. Of course, of the same size sa imuhang given matrix. So, we have A squared. Wala na ni underface. So, we have A squared. Ay, sorry. Wait lang ha. Okay, we have A squared. Okay, A, 1, 3, 4, 5. Nananadere. Then square, you square it. Minus 6 times A minus 7 times the identity matrix. When you square this matrix, it will result to this matrix. Okay, again, multiplication of matrices. 1 times 1 plus 3 times 4. 1 times 3 plus 3 times 5. 4 times 1 plus 5 times 4. Another A. And then we have 4 times 3 plus 5 times 5. Manisha. So we resulted to this matrix. This is this matrix for this. Minus 6. We distribute 6. This is 6 is scalar. So we distribute 6 to this matrix. So we have 6, 18, 14, and 30. Minus 7. 7 again is scalar multiplied to the identity matrix. We have 7, 0, 0, 7. Then we compute. We have 13 minus 6 minus 7, 0. 18 minus 18 minus 0, 0. 24 minus 24 minus 0 is 0. 37 minus 30 minus 7 is 0. This is equal to, again, the 0 matrix. So we equate this. Once we achieve with this last process here, now our characteristic polynomial is correct. Questions on Cayley-Hamilton theorem? Clarifications? So again, for your midterm exam, right? Midterm exam is on May 20, I believe so. Nag-post na ba? Wala pa. I think December gihapon, same venue. Anyway, if there are changes, prior to your schedule, I will post it or I will update you in the GC. Ako na ibalan is May 20, the same time, 7 a.m. Make sure you arrive on time because there are a lot of computations here. So we can start on time. And then, 7 a.m. ICT AVR ba mo? ICT AVR mo na butang. So, the same venue, same time, May 20. Coverage starts with, of course, vector space, subspace, linear independence, basis, span, eigenvalues and eigenvectors, and Cayley-Hamilton theorem. Right? Any other questions, clarifications? Before we will end with our discussion. We don't have any more time to have a quiz for this, so you practice at home. Right? So make sure you practice because medyo taas-taas yung process, ani. Questions, clarifications? May I request everyone to please open their camera before we end our discussion so I can have documentation. Right. There is only one panel, no? You ready? Hey, wala pa ang uban. Sige, one panel only. Ready? Ready, one. Napay nag-open. Okay, ready? 1, 2, 3. Okay, done. Thank you so much, everyone, for joining today's meeting. See you on a final exam. I hope you study, no? This will be our last meeting, so good luck. Bye, everyone.
Goodbye, ma'am. Thank you, ma'am.
Thank you, ma'am.